Hello. Now we will talk about the conjugate complex numbers in this video. Suppose you have two real numbers. You can call them z1 and z2. So two complex numbers z1 and z2 are called conjugates of each other if we say that both complex numbers are conjugates of each other if these two conditions are hold. The first condition is both have same real part. Okay, so both have the same real parts means if z1 is a plus b iota and z2 is c plus d iota, their real parts are a and c. So the first condition says that both must have the same real part. That means the real part of z1, which is a, and the real part of z2, which is c, must be same. What does that mean? A must be equal to c. Okay? So the real part of z1 and the real part of z2. Okay? Yeah, they must be same. And the second condition is their imaginary parts are opposite. Okay, what does that mean? This means, let's look. Z1 has imaginary part B, Z2 has imaginary part D. They must be opposite. What does that mean? This means B must be equal to the opposite of D. That means B must be equal to minus D. So if this is the case, then we say that both numbers are conjugates of each other. Okay? So in other words, if you have a single number z, you can find its conjugate by using these two conditions. Okay? Okay, let's look. Or in other words, I can say that if I have a complex number z, then its conjugate is, so first of all, let's look at the notation. The conjugate, if z is the complex number, then its conjugate is denoted by z bar. With this line, I denote its conjugate, okay? So z bar is the conjugate. So I will write z bar is equal to, so this is the conjugate. So this is the complex number and this is the conjugate. What are the conditions? The condition says if two numbers are conjugates of each other, then they have the same real part. Their real part must be same. So A is equal to C. Sorry, I should write A is equal to C. Okay? So that means this A must be the same in the conjugate because it says the real part must be same plus imaginary part must be the opposite of the imaginary part. So what is the imaginary part here? It is B. So I will write minus B here. Okay? So if you have a complex number A plus B iota, then its conjugate is A minus B iota. Okay? If I apply this definition, so to any complex number, it will change the sign of this imaginary number, right? It will take this real part as it is, but it will change the sign of this imaginary part. Okay, let's do some examples. So in this example, we will find the conjugate of 7 minus 5 iota. Okay, so I have 7 minus 5 iota. So I will write its conjugate. I told you the conjugate is denoted by bar. So if I write its conjugate, I will write it bar, right? So when we'll apply this conjugate to the number, the real part will remains the same, but the imaginary part will be flipped. Okay, what does that mean? I told you, when we write the conjugate, we turn the imaginary part to the other side, to the other direction, to the opposite direction. If it is plus, I make it minus. If it is already minus, I will make it plus. What does that mean? This imaginary part is negative, so I will make it plus 5 iota. So this is the solution. So this is the conjugate of this number, okay? So let's do one more example. So here you have a complex number. You have to find its conjugate, okay? So in order to find the conjugate, I will write 2 plus iota, the bar over there. What that means, I have to take its conjugate. Okay, if I apply this conjugate to this number, this real part will remains the same, but this imaginary part, which is 1, will turn into minus 1. So I will write minus iota. So this is the answer, okay? So always when we take the conjugate, we write the real part as it is, and if we have this imaginary part, we change its sign, okay? Let's do another example. In this example, we have to find the conjugate of 7. Okay, here is the solution. Since I told you, you can write 7 as 7 plus 0 iota, right? So if you take its conjugate, you can write this bar. Now, if I apply this conjugate to the number, the real part will remain the same, but this is the imaginary part. I will write minus, but there is no purpose. If you write this thing, it will be again 0, so that is not needed. So what does that mean? This means if you have pure real number, you can see this is pure real number because there is no iota involved in this term. So if there is a real number, a complex number which has no iota terms involved in it, so if you have such kind of a number, then its conjugate will get unchanged, right? So its conjugate will not be changed. The conjugate will only be changed when you have a non-zero imaginary part. Okay, since in this term the imaginary part was 0, so therefore the term was unchanged. Okay, so let's do another example. Find the conjugate of minus 5 iota. Here is the solution. So first of all, you will write into a plus b iota. You know, minus 5 iota can be written as 0 minus 5 iota. You know, okay, here is the real part and here is the imaginary part. Okay, so you have to take its conjugate, apply the conjugate on both sides. Now, how can I take the conjugate? When will I apply the conjugate to the number? I will write the real part as it is, but I will change the sign of the imaginary part. Since it is negative 5, I will write plus 5 iota. So the answer is 5 iota. So look, in this example, the number was pure imaginary, okay? In the previous example, the number was pure real. In this example, the number was pure imaginary. If you have a real number, its conjugate is the same. But if you have a pure imaginary number, its conjugate is just the opposite of that number, right? But if the number is mixed, Number is mixed mean it has real part as well as imaginary part. Neither it is pure real nor it is pure imaginary. So if you have such kind of number, then then you will make no change in the real part and you will flip the imaginary part of this number. Okay, now let's look at the geometric interpretation of the conjugate of a complex number. Okay, look at the graph. So suppose you have a complex number a plus b iota, and you can convert it into a comma b, right? So you suppose that this is our b, this point, and this point is our a, okay? Then in order to find the corresponding point here, we will draw two lines, the one here, the perpendicular line, and the other one here, okay? Then a point where they both are meeting, this one, I marked this point, and then this is the actually the vector is the point. In order to draw the vector, I will draw a vector at pointing at this point but starting from the origin, okay? Okay, now I will remove these lines because they are not needed. Here I have this is equal to a and this is b. So this point is a comma b. Suppose this is a complex number, or you can write it as a minus b, a plus b iota. Since its conjugate is a minus b iota, so where is it is a minus b iota, okay? So if I draw a minus b iota, it will be like a comma minus b. Okay, let me change the color for these. Okay, so I have to draw these 2 points. So the a point is the same, right? But b point is opposite of this b, right? Since this b is this way on the top, so my new b is negative b, so it must be below, okay? So the b should be here somewhere, okay? So I need to draw the point by joining these 2 points. How can I draw it? I will draw 2 lines, one line passing through this point and the other line passing through this point, and then I will draw a point here because this is the point of intersection. Okay, now here I will draw a vector starting from here and whose head is at this point. So here is the vector, right? Now you can check. This new vector is just the reflection of this original vector, okay? So for example, if this is the mirror, and here you have any vector, its conjugate should be the reflection here, okay? For example, you have this vector here, its reflection must be this vector here, okay? Just the same magnitude and the same angle, okay? So this in this way we can write the conjugate of a complex number, okay, by just taking the reflection along this mirror. If this is the mirror, just write the same thing but on the other side, on the opposite side. So this is the geometric interpretation.